Okay, so today we'll discuss some important things in the Terraform, mostly from the interview wise also important. So here we have like a count and for each. Say, I want to create multiple resources. Say, if I have 10 resources need to be created, I no need to specify 10 resource blocks in my resource, like in my in.tf file. So I want to create 10 EC2 instances. I no need to create 10 files we no need to create. So what is the best thing what we can do is we can use like a count and for each. That means I want to create 10 resources. Then in the single resource block itself, I'm going to create like a uh, 10 replicas or 10 count of resources I want to create. Then I can use count and for each. Okay, so we have a small difference between them, and it's very, very important. We need to understand what is the difference between count and for each. So then here, what is the count is? The count is going to create identical kind of resources. The count is going to create identical kind of resources. Say suppose here I given count instance count in the variable. If I give 10 different instances are getting created, and for each instance we are getting an index of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that here, that 0 will represent first instance, 1 will represent second instance. Like that we are getting the 10 resources are getting created. But what is the problem with the count is like identical kind of resources. That means all are going to use same instance, and all are going to use same AMI, same instance type, security group, region, all we are getting identical kind of things. That is the if we want to create a identical kind of resources, then we need to use the count. But I want to create 10 resources, but I want to use different key pairs. I want to use different security groups. All I don't want to keep in the single one. Okay, so at that moment, we need to use the count with for each. Okay, so when we are using count is the count we are using for the identical kind of resources, and in which scenario we are going to use for each? In which scenario you are going to use the for each? Say we want to pass different values for the different resources. All I don't want identical kind of things. All I don't want identical kind of things. Then at that moment I'm going to use the for each. So now here if I use the count, normally I can specify directly the value itself, but that count I'm passing from the variable I'm passing. Means we have the instance count is a variable, and from that we are going to pass it. Okay, so from the count we are going to pass that one. Okay, so then here for the each what is that index is? Say 0, 1, 2, 3. I don't want to give the similar name for this. By using this like as an environment variable I'm passing, what are the names I'm getting for the 10 instances? In the GUI wise also I'm getting app-1, app-0, app-1, app-2. Like this I'm getting different names I'm getting. Okay. So anyhow Terraform also internally will manage that. For the GUI also, like in the GUI also I'm going to provide that. Okay. So then so now here I have declared a list of variables. How many regions I have specified here? So 2 zones I have specified. 1A, 1B, and I am specifying 2 different subnets also. Then what is going to happen here is when I create the resources, like count is how many two we are getting, and automatically 2 instances are getting created. So 2 instances dynamically also we can pass those values. Okay, then say here. Now, what is the purpose of this for each is I want to give the different names for the each bucket. Here I'm going to specify buckets is okay, say log production assets backup for each value. That means this is going to create three buckets with the three different names it is getting created. Okay, so what is that meaning is, instead of using the count, I don't want to create the similar identical kind of names I don't want to use. I want to pass the different values for my different things. At that use case, I'm going to use the for each. Okay, so with the for each, I need to give the list of values, and that list of values I'm going to pass it. Okay, that list of values I'm passing to those resources. With this, what is the advantage is, you no need to provision the similar kind of resources. You no need to provide the similar kind of resources. There we are in the variables, we have like a list or map, multiple values we have, and those values I'm assigning to my resource. Whenever we want to add multiple security group rules, subnets, different key pairs, at that moment we are going to use a for each kind of thing. At that moment we are going to use for each we are going to use. Then one more important important uh, thing is, this is going to start from the uh, zero. Okay, so need to start. It starts from the zero that index is getting started. Okay, and we have lot of meta arguments we have. This is also one of the important meta argument. Like as we discussed, count, for each, depends on, provider, life cycle, provisioner. These are the different life cycle, meta argument rules we have. Already we discussed count and for each. Depends on, when we have the explicit dependency among the resources we are going to use depends on, and which provider it need to use, and on that what are the resources, data sources we have, that's we can explicitly declare that using the provider. And we'll discuss life cycle also. Then what are the provisioners we have is, we have three types of provisioners we have. So what are those types of provisioners we have? Local exec, remote exec, and we have file provisioner. So these all we are calling them as the meta arguments. In the interview wise, like people will ask us, what is the meaning of meta arguments? Count is, it's a simple, say multiple copies or identical kind of multiple copies if we want, then we are going to use the counter. Okay, so count index starts from 0, and for each we are going to use, we want to pass the different set of values, not identical, and those values we are passing from the map or set, and those details we are passing to the resources. Okay, so each value instance type from the list it is taking, that each value is, say here we have three resources or two resources. For one I'm giving t3.micro, for another one I'm giving t3.small. But in the previous environment, if I use the count, similar identical kind of resources are getting created, similar identical kind of resources. And one more meta argument is, depends on, if you have any explicit dependencies among the resources, business wise we have this kind of requirement, then we are going to use the depends on feature. Okay, so depends on feature we are going to use. So now here, what is this meaning is, this resource AWS instance server resource is depends on S3 like a bucket logs. If that S3 bucket with the name logs has been created, then only I want to create my EC2 instance. I don't have any dependency between those two AWS wise, but business wise, I have like my instance logs I want to store into that S3 bucket. That is the reason first I'm provisioning that resource. Okay, then for the second resource, we are using the keyword depends on, and based on that, we are going to create it. Based on that, we are going to create that one. And the provider already we configured that provider. So multiple providers also will use for the multi-cloud or multiple environments if we want to use. And we'll discuss that life cycle also. Today we'll discuss life cycle also, very, very important. And provisioners, we have at the final stage. So we want to execute some of the configuration kind of things, like we want to run the commands, or like we want to prevent the destroy kind of operations. At that moment, we are going to use like a provisioner kind of things. So provisioner kind of resources we are going to create. Okay. So now here we have this provisioner is a remote exec. In this resource block, we kept this provisioner. At that moment, what is going to happen is that command is going to execute on the provisioner, like this remote exec. Once this instance has been provisioned, like a sudo apt update or apt install, these all is going to provision. In the AWS wise, if we want to use any of the native service, in the instance itself, we can use in the instance itself we can use user data. So in the user data also, once the instance has been provisioned, we can run those scripts. The user data we can keep, and those data we can keep. And for the remote exec to work, definitely we require the connection also. Okay, so what is the meaning of connection is, if that remote instance is a Linux instance, then we are using SSH, and that key pair, what is the key we have used that we are passing, and that host also like a self-host, with that we are going to execute that. So now here, what is the provisioner we have used inside the resources? Remote exec, and that remote exec, like in the inline, we are going to specify the commands, or we can execute the scripts also. Okay, so that's these all the different meta arguments. We'll discuss these provisioners also. For each, count, depends on, provider, life cycle, provisioners. Okay, so these all the different kind of like meta arguments we have. Then what are the meaning of provisioners are? Like once the resource has been provisioned, on the remote resources, I want to copy some files, or on remote missions, I want to execute some commands, or locally after provisioning, I want to perform some automation. At that moment, I'll use the local exec kind of provisioner I'm going to use. Okay, so now here we have the provisioners like file, remote exec, local exec, and even we can integrate with the configuration management tools like Ansible, Puppet, Chef, Salt. These kind of tools also we can use. And to establish to that remote missions, definitely we require the connections also. And those connection blocks we are going to use like a SSH or WinRM. If the remote mission is Linux, we are using SSH. If it is Windows, we are using WinRM, we are using. Okay, so then, say here we are going to use the resources AWS instance, web we are created. In that we are establishing the connection is SSH. Then like we are copying the provisionaries file. Then in the source, in that where we are running Terraform, I have this SH file, and that is getting copied into on the remote instance into the temp directory. Okay, then this is the provisioner we used is file provisioner. Remote exec is like that scripts I want to execute. So first I'm giving the execute permissions by using chmod, then I'm executing that script. Okay, so then I want to send an email kind of notification, or I want to collect those IPs locally. I want to store those IPs in a file. So then, like once the resource has been provisioned, that's not running on the remote mission. On the local mission where we are running Terraform, there it is getting executing. So that is the purpose we are going to use local EXEC. We are going to use. So we are going to use the local EXEC. We are going to use. Okay, so for that purpose we are going to use the local exec. We are going to use it. Okay, say here sometimes each and every time to execute the local exec, we no need to create the resource. So for that purpose we are going to use like null resource. What is that null resource also we'll discuss. That is also very important. So now here for the provisional local ex is also I created a resource, an easy to instance. But sometimes I don't want to provision instance, but I want to execute something on the local mission. At that moment, we are going to specify a null resource also. So now what it is doing is it saves the file locally and send the notifications or email notifications. Those also we can do. Even I want to call the Ansible kind of scripts, those kind of things also locally after infrastructure provisioning, I'm calling the Ansible kind of scripts. Okay, so what like a very limited operations we have instead of using the script we are using for the configuration management, better to use the Ansible or Chef or Puppet kind of tool, and those scripts we can integrate with the local EXEC, and at the time of instance like infrastructure provisioning, we can call that. Okay, so that is one of the best practice we can use. Okay, so what is the null resources? We no need to provision a resource. Okay, so null resource not like to execute only a local EXEC provisioning a null resource is not a real use case. Instead of creating a AWS EC2 instance or resource on top of that, instead of keeping a local EXEC, you can specify that like local EXEC provisioner inside a null resource we are creating. That means it's not creating a resource, but what it is doing is it is executing that command. It is executing that command, and for that purpose, we are going to use the local EXEC we are using. So that means you no need to create a resource, but you want to perform some automation. At that moment, we are using the null resource. At that moment, we are creating null underscore resource is one of the keyword. Okay, so we don't want to provision the resource, but I want to execute local EXEC kind of thing. Then I'm going to use the null resource. So we are copying that index.html remote EXEC we are performing. And local EXEC, I'm just printing that local website is working with this IP like that. I'm giving that. Okay, so another very important use case is we have the Terraform lifecycle. Say in the Terraform lifecycle, like in the resource block itself, we are going to specify lifecycle also. And this is also one of the important Terraform meta argument. And what is the purpose we are going to use that meta argument? We have four types of meta arguments we have in the lifecycle. That is like a create before destroy, prevent destroy, ignore changes, and replace triggered by. So these all the four we need to remember, and people directly they don't ask what are the life cycle rules. They will ask the use case. Then you need to tell like we are going to use the life cycle, and this life cycle rule we are going to use for this requirement. So what is the meaning of prevent destroy is equal to true is have some of the production servers, and I don't want to accidental termination. I want to manage. Okay, I want to destroy. Say I want to manage those. I want to prevent those destroy. That means if someone Terraform destroy, if they run the command, all the resources are getting destroyed. But I want to prevent that, because maybe if entry level person, if you run accidentally Terraform destroy, all the resources are getting destroyed. Okay, so at that moment, to prevent that kind of accidental destroy, we are using the lifecycle rule. And what is that lifecycle rule we are using? What is the lifecycle rule we are using here? Prevent underscore destroy. In the resource block, we are keeping that lifecycle meta argument. In that, we are keeping prevent destroy. And with that, we are going to manage that. Okay, so then even create before destroy. So that means when we use the taint or replace kind of operations, one resource is getting deleted, one more resource is getting created. But if by default, what is the behavior is the first resource is getting deleted. After that, new resource will provision. But if I use the option create before destroy lifecycle rule, if I use, what is going to happen is first the resource is getting created, and that should be the standby. Later, the new resource will be destroyed. Sorry, old resource is getting destroyed. Okay, so that's the option we are going to use create before destroy. And what is the meaning of ignore changes is we have a command like Terraform refresh. If any of the configuration changes has been performed on the actual resources, when we do the Terraform refresh, it's going to bring those changes to the local machine. But I don't want to get all those details, for some of the tags, some small configuration changes. I don't want to get into my state file. Then those resources, I can specify ignore underscore changes. And whenever we have the dependency of the resources, we may have sometimes we may be performing some changes are triggered not manually. That's maybe another resource is getting created those changes. At that moment, who is going to trigger that replacement? That's we are going to manage. Okay, so replace triggered by, but prevent destroy, create before destroy are the important lifecycle rules. Okay, so now here in the resource, in the lifecycle, I'm keeping create before destroy. Then when that resource has been tainted, at that moment, what is going to happen is first that resource is getting created. After that itself, the new resource is getting created. Okay, so for that purpose, we are going to use create before destroy kind of lifecycle rule. Okay, so whenever we are updating that or maybe taint kind of operations, that resource is not getting deleted first, because business wise that is important. Then we are going to manage it. Then prevent destroy, even if someone accidentally deleted, say even if you keep prevent destroy equal to true, so that resource is getting deleted from that resource is getting deleted from where? From the GUI wise, if the user deleted, that's going to be deleted. But there also on the Terraform level also, we need to manage that. The Terraform level also, we need to manage that one. Okay, so that depends upon the, this is prevents from the Terraform destroy, it is going to be managed. Okay, so from the Terraform destroy, this is going to manage it. Then ignore changes. Say now here, like in the lifecycle rule, the tags of this, like if the owner of that resource has been changed in the tag, that I don't want to update in my state file. That means even if that owner changes also, or name changes also, like that tag we need to specify. If any of the tag has been done, that's not going to be considered. That means that's ignoring that change. Okay, so that's we can manage, and even in the auto scaling also that resources we can ignore. Replace triggered by, okay, so that's like a even if any of the dependency of the resource is modified, also that dependent resource also is getting deleted. That resource also is getting deleted. That means like here we have, if any KMS key changes, automatically it's going to replace that like EBS volume. That means it's not manually we are triggering, but we have the dependency among the resources. That level we are going to perform. Okay, so these all the four provisioners, life cycle rules we have. What are those? Create before destroy, prevent destroy, ignore changes, and replace triggered by. Okay, so already we discussed a null resource. To manage the mostly the local EXEC, I don't want to perform like scripts locally. If we want to perform, then we are creating null resource. Okay, so with the local EXEC, if we want to perform some operation, each and every time instance creation is expensive kind of thing, then we are going to use like a local EXEC we are creating. Okay, so these even we can integrate with the like Jenkins or with the Ansible kind of scripts also. We can call it. Okay, so that is like even one of the important in interview question, like the null resource. The null resource also is important use case. Then like one more like important topic is workspace. So what is the concept of workspace is like we have the different environments. We can use the Terraform modules for the different environments we can pass, and for each environment we are passing the values from Terraform dot tf bars. But I want to store those state files for the different environments. I want to keep in the different workspaces we are going to keep. Means for dev, I'm creating one workspace. Normally, if you want a different workspaces, means you need to switch across multiple directories. But you no need to switch across the multiple directories. When you initialize, your default directory itself is becoming one workspace. But this workspace concept is, I want to maintain logically different kind of workspaces on the same directory. So for that purpose, we are using Terraform Workspace. So we can create our own isolated state files, and those configuration files we are going to create. So that means the different environments I'm going to pass that modules and values I'm passing from Terraform.tf vars, but the state file I'm going to keep in the different folders and directories I no need to maintain. By creating the Terraform workspace, we can manage work with the multiple infrastructure. Okay, so by default, Terraform workspace list will show us what are the workspaces, and the current workspace it shows Terraform workspace show, and we can create a new workspace by using Terraform workspace new, and which if we want to switch to another one, then Terraform workspace select that new workspace. Say suppose I want to work first on the dev environment, then create a dev environment, then choose that. Then once your work is done, I want to move to QA environment. Then choose the workspace to QA. Then the QA environment values it is taking from Terraform.tf state. Then in the staging environment, the workspace I'm using staging workspace. Like this, we can switch from the multiple workspaces, we can switch it. Okay, and when you use that like Terraform init, your directory itself is becoming a Terraform workspace. One environment we can manage, but when we are using the different workspaces are, we want to manage multiple environments, then we are going to create different workspaces we are going to create. Okay, so now here this is the environment value or parameter we are taking. That means even that bucket also is different for the different workspaces we are creating, and the state file also we are managing the different. Means if we want to work with the multi-environment, then we need to use the Terraform modules, Terraform.tf vars, and finally those state files all we are storing in the workspace we are going to store it. Okay, so that's like we need to switch among the workspace. Okay, so workspace variables we are passing from Terraform.tf vars. That scripts we are managing from modules. Okay, so like this here we are going to manage the same configuration files, modules, but we are managing for the different environments. Okay, for the different environments we are managing. For that purpose, we are using the workspaces. Even for the different environments, we are going to configure different backends also. Okay, all storing in the same state file is not a best practice. The dev state file is different, QA state file is different, for production state file is different. That from the Terraform workspace, what is the value we have? Based on that, we are going to store that in the Terraform.tf state.
Sir, in this case, all workspaces stored in one directory, sir.
Directory may be there, but that in that again the bucket may be name same, but in that the folders are different names.
Folders different names, but total folders are stored in one folder.
That's we are calling as bucket.
Yes, sir. Okay.
Bucket name may be
Okay,
same,
sir.
but in that we have the different folders.
Okay, sir. Thank you.
Okay. So then, or we can create different buckets also, we can create, that depends on us. Okay. But with the workspace, we are separating them.
Yes, yes, sir.
Okay. So otherwise, resource names, all those will get the conflicts also. And for the production, already the dev having the same resource, for production that assumes that resource is already existing.
Yes.
Okay. So that's the reason we need to use modules. We are passing those modules with the different directories using Terraform.tf vars, and we are managing from the workspaces we are managing. Now here in this environment, this Terraform workspace, this is the environment value. If it is dev workspace, dev value would be taken. For production, production value would be taken. In that the file is Terraform.tf state. The file is Terraform.tf state is getting created. Okay. And what is the
Your
meaning
voice
of...
is not audible.
Yeah, is it
Some
fine now?
disturbance. Some disturbance is coming.
Some network issue from my side. Yeah, is it fine now?
Yeah, right now
Okay.
good.
Yeah. So now here we need to understand dry run. So what is the concept of dry run is, in the production environments, before doing the actual running, like we are going to do the dry run kind of things also. That means it won't
Still,
execute,
it is
but
breaking, sir. Voice.
yeah. So by using the dry run, what is going to happen is, it is going to like uh, show the what are the actual things are happening, but it's not executing. Okay, it's not going to execute. That means here we are going to save that Terraform plan hyphen out equal to TF plan. Okay, that means we are running that using the plan and taking that output, and we will send that to the client also if required. Then with an approval only, we are going to perform that changes. So for the first time or mostly whenever we are doing it, okay, what we are going to do is we are going to use the like dry run, like with the plan, we are saving that into TF plan that we are sending to the client, and with an approval only we are performing those changes. Okay, so with approval only we are going to perform. This is one of the best practice we need to take care. Okay, and even with the Jenkins file also we can integrate this with the pipeline we'll discuss. That means in the DevOps pipeline we are integrating even Terraform also. Mostly in the CD we are provisioning the infrastructure. At that moment we'll discuss this. Say lab wise, like everyone try to finish that modules we have, right? CLI configurations modules. Those all try to finish once. Okay, so in that itself, we have the state and importing the resources, all those we have, and then how to create the modules, all those try to create once. Okay, so whatever we have discussed today, mostly in the interview, these all the questions people will ask us in the meta arguments, life cycle rules, provisioners, providers. Okay, so count and for each. So these all the common interview scenarios people will ask us. Okay.
Okay, sir.
Yeah. What about Sanjay? Have done those?